Hello everybody! So right now we are going to talk about the derivatives of inverse trigonometric function. So in this section, we are going to explore the process of finding the derivatives of the 6 inverse trigonometric functions. So let's take a look on those 6. So here is the theorem illustrating the derivatives of inverse trigonometric functions. So let u be the differentiable function of x. So for the derivative of arcsine u, we have u prime over square root of 1 minus u squared. And for the derivative of arctangent u, we have u prime over 1 plus u squared. And for the derivative of arcsecant u, we have u prime over the absolute value of u, square root of u squared minus 1. And it can be noted that the derivative of arc cosine u here and the arc cotangent u as well as the arc cosecant u are the negatives of the derivatives of arc sine u, arc tangent u, and arc secant u respectively. So let us see and discuss first the proof for these three. Right? So first off, we have the finding the derivative for arc sine x. So we're going to use x as our variable here to further illustrate and explain how we get that kind of derivative for the arc sine. We can also denote this as y. Okay, we can replace f of x by y. So it will become y is equals to sine or arc sine x. Okay, and by the use of the multiplication rule of equality, we can multiply both side by sine. So we have sine y is equals to sine arc sine x. Since we have negative 1 and positive 1 exponent here of sine, we can cancel this too. So our first equation will become sine y is equals to x. And next thing that we need to do, we need to differentiate both sides of the equation with respect to x. So we need to get the derivative of sine y as well as the derivative of x. So derivative of sine y will be cosine y dy over dx. And for the derivative of x is equals to 1. Right? And now we need to solve for the value of dy over dx. So that's why we have here dy over dx is equals to 1 over cosine y. This will become our equation 2. And we know that by the use of Pythagorean identity, cosine squared y plus sine squared y is equals to 1. So from this identity, we can get the value of cosine y. So therefore, for our cosine y, we have the value of square root of 1 minus sine squared y. So we need to put this value of cosine y to the equation 2. And it will become dy over dx is equals to, so from this equation 2 here, it will become 1 over the square root of 1 minus sine squared y because we input this to this, right? And now, since sine y is equals to x, as you can see from the equation 1, we are going to use that equation so that our sine squared y will become x squared. So we have dy over dx is equals to 1 over square root of 1 minus x squared. So we just replace the sine squared y to x squared. Okay, and see, so it means in summary, the derivative for arc sine x is equals to 1 over square root of 1 minus x squared. Or in the other books, we can also represent it, or they are representing it as the derivative of arc sine u is equals to u prime over the square root of 1 minus u squared. Right, so we're done with this, and let's move forward for the proving of the derivative, finding the arctan u or arctan x. We're going to use x again as our variable. We can also show this as y is equals to arctan or arctangent x. And by the use of multiplication rule of equality, we can multiply tangent to both sides of the equation in order to cancel this 2, because we have negative and positive 1 as our exponent. So our equation will become tangent y is equals to x. This is our equation 1. So differentiating both sides of the equation with respect to x, we need to get the derivative of tan y as well as the derivative of x. And the derivative of tan y is secant squared y, dy over dx. And the derivative of x is 1. So solve for dy over dx, then we will have the equation 2, which is 1 over secant squared y. And next, we are going to use again the Pythagorean identity. Tangent squared y plus 1 is equals to secant squared y. We need to put this value of secant squared y to equation 2. Right, as you can see here. And now it will become dy over dx is equals to 1 plus tangent squared y. And since tan y is equals to x from our equation 1, then the 1 over 1 plus tangent squared y will become dy over dx is equals to 1 plus 1 plus 1 over 1 plus x squared. Okay, because the value of tan y here in our first equation is x. That's why from this part, by the use of this first equation, it will become dy over dx is equals to 1 over 1 plus x squared. And so in summary, the derivative for finding the arctangent x will be 1 over 1 plus x squared, or in the other books, they are also using the derivative of arctangent u is u prime over 1 plus u squared, or they are denoting it as u, or they are using u as the variable. And let's take a look for the third one, which is the derivative of the arcsecant x. So again, we can represent this as y is equals to secant or arcsecant x. Okay, and by the use of multiplication rule of equality, we can multiply to both sides of the equation by secant. So we can cancel this 2 since we have positive and negative exponent of the secant. And now our first equation will become secant y is equals to x. And again, we need to differentiate both sides of the equation with respect to x. So we need to get the derivative of secant y and also the derivative of x. And the derivative of secant y is secant y tangent y dy over dx. And the derivative for x is 1. We need again to solve for the dy over dx. Then we have dy over dx is equals to 1 over secant y tangent y. So this will be the representation for our equation number 2. And again, we are going to use the Pythagorean identity. So we have tangent squared y plus 1 is equals to secant squared y. So to get the tangent y, or to get the value of tangent y, we need to get the square root of both of the equation. So the value for our tangent y is equals to the square root of secant squared y minus 1. And again, we need to insert the value of this tan y or tangent y to equation 2. So we have dy over dx is equals to secant y squared of secant squared y minus 1. Let us continue the process. So we're here, we stop here. We have dy over dx is equals to 1 over secant y squared of secant squared y minus x. And since secant y is equals to x from the equation 1, then we are going to replace again the secant y by x. So it will become dy over dx is equals to 1 over the absolute value of x squared of x squared minus 1. And now in summary, for getting the arc secant x, the derivative is 1 over the absolute value of x squared of x squared minus 1. And in other books, we can also represent it, or they are representing it as the derivative of arc secant u is u prime over the absolute value of u times the square root of u squared minus 1. And now let us start with our illustrative examples. Let us analyze the following. Find the derivative of the given function. So we have the given y is equals to arc sine 4x. So for our solution, we're going to get first the value of u. Okay, so we let u, which is 4x, and then our u prime derivative for the u is 4. Alright, and then just plugging in all of the value by the use or in the derivative format that we have is u prime over square root of 1 minus u squared. So we have y prime is equals to 4 over the square root of 1 minus 4x squared. Right? And then next is just to solve for this. So our final answer, we have the derivative for arc sine 4x is equals to 4 over square root of 1 minus 16x squared. Right, so let's move forward to our second example. Find the derivative of the given function. We have y is equals to arc cosine 2/3 x. So we let u, which will be our 2/3 x, then u prime will be 2/3. You just plugging in this information to our format for the derivative of finding arc cosine. So since this is arc cosine, this is the negative format of arc sine. So we have y prime is equals to negative 2/3 over square root of 1 minus 2/3 x squared. So first we're just going to solve for this. We have y prime is equals to negative 2/3 over 1 minus 4 over 9x squared. And the next thing that we're going to do is we need to get the difference of those terms inside the radical in the denominator. Okay, so to get that, we have y prime is equals to negative 2/3 the numerator times the reciprocal of the fraction inside the radical of the denominator. So we have square root of 9 over square root of 9 minus 4x squared. And the square root of 9 is 3. So we can cancel this 2. And we can get this as our final. Y prime is equals to negative 2 over square root of 9 minus 4x squared. Okay. Next, we need to find the derivative of arc secant 3x. So we are going to use this format for getting derivative of arc secant u. It is u prime over the absolute value of u times the radical times the square root of u squared minus 1. So we let u our 3x, then our u prime is equals to 3. So just plugging in all this information to our format of finding derivative of the arcsecant u. So we have y prime is equals to 3 over absolute value of 3x times square root of 3x squared minus 1. So this, as you can see, we have 3 here on the numerator. So we can cancel these 2 and it will become y prime is equals to 1 over the absolute value of x, and then solve for 3x squared, so we have square root of 9x squared minus 1. So our final answer for getting the derivative of arc secant 3x is 1 over absolute value of x square root of 9x squared minus 1. Alright, now we have here finding the derivative of the given function using the chain rule. So, of course, you can be able to use this format for getting the arc cosine u. It will be the negative 1 over square root of 1 minus u squared times du over dx. So our given will be y is equals to arc cosine sine x, and we need to get the derivative of this. For our solution first, just plugging in the sine x to our format u, so sine x will be our u. So y prime is equals to negative 1 over square root of 1 minus our u squared. It will become sine x squared times du over dx, or du over dx sine x. Right? So we need to get the derivative of sine x as well. And the derivative of sine x will be cosine x. That's why we have y prime is equals to negative 1 over square root of 1 minus sine squared x cosine x. And as you can see, there is also a Pythagorean identity here. So it will become, or the 1 minus sine squared x is equals to cosine squared x. So that's why it will become y prime is equals to negative 1 over cosine squared x times cosine x. And we need to multiply the numerator here, negative 1 to cosine x. So we can get y prime is equals to negative cosine x over cosine x. And then we can cancel these two. So our final answer for getting the derivative of arc cosine sine x is negative 1. Now let's move forward and get the higher order derivative of inverse trigonometric function. So we are going to get the third derivative of y is equals to arc cosine sine 2x. Alright, so we can use this format again, just plugging in our sine 2x. It will serve as our u. So it will become y prime is equals to negative 1 over square root of 1 minus sine 2x squared times the derivative of sine 2x. And the derivative of sine 2x, when we differentiate it, is 2 cosine 2x. So it will become y prime is equals to negative 1 over square root of 1 minus sine squared 2x times 2 cosine 2x. And as you can see here in the denominator, we also have the Pythagorean identity. So 1 minus sine squared 2x here, it will become cosine squared 2x, like this one. Okay, through the use of Pythagorean identity. So we have y prime is equals to negative 1 over square root of cosine squared 2x times 2 cosine 2x. And by multiplying those numerator, we'll get y prime is equals to negative 2 cosine 2x over cosine 2x. So since we have 2 cosine 2x here, numerator and denominator, our final answer will be, our first derivative will be negative 2, right? Because we are looking for the third derivative pala, okay? So we got the first derivative already, and let us continue. We have y prime is equals to negative 2 already. And next thing, we are going to get the derivative of this y prime, or the derivative of the first derivative, right? So the derivative of negative 2 is 0. So this will be our second derivative. And that means that our third derivative is also 0. Okay, so our third derivative for arc cosine sine 2x is 0. And now we are going to use the implicit differentiation to find the derivative of arc sine x plus arc sine y is equals to pi over 2. As you can see, we have x here and we have y here, both in the left side of the equation. So in our solution, well, of course, first, by the use of our rule for getting the derivative of arc sine, which is 1 over square root of 1 minus x squared, or u prime over square root of 1 minus u squared. So for the derivative of arc sine x, we have here 1 minus the 1 over square root of 1 minus x squared, plus the derivative for arc sine y is this 1 over square root of 1 minus y squared, dy over dx. So we need to put dy over dx in order for us to make sure or show that we are getting the differentiation of this function implicitly. And the derivative for the pi over 2 is 0, right? And next thing is we need to transpose this first this x and all those terms that has y variable stay aside here on the left side, and on the right side we're going to put together all the x's. So we have 1 over square root of 1 minus y squared dy over dx is equals to, since we transpose the positive 1 over square root of 1 minus x squared, it will become negative 1 over square root of 1 minus x squared. And then next step then we need to do is to solve for the dy over dx. So solving for dy over dx, it will become dy over dx is equals to negative square root of 1 minus y squared over square root of 1 minus x squared. So it means our dy over dx, or the derivative of arc sine x plus arc sine y is equals to pi over 2 is equals to negative square root of 1 minus y squared over 1 minus x squared. Or kung dito lang kayo huminto, halimbawa, it's okay as well, because it's all the same with this one. Okay? So for your own practice, you can try to solve for this. Find the derivative of the following functions. So for our A, you can find the derivative of y is equals to r cosine 4x. And for B, you can find the y is equals to arc secant 2x. Right? So that will be all for today for finding the derivative of inverse trigonometric function. Thank you so much.